Okay, so think about this for a second. Every single time you grab something off a store shelf, you're looking at the final, tiny piece of this gigantic, complex puzzle. And behind that simple act, there's this hidden world of math and logistics and pure strategy, all designed to get that one product into your hands as efficiently as possible. So today, we're going to pull back that curtain and look at the hidden science of the shelf.
So what do they have in common? Well, it turns out a whole lot more than you'd think. They are both incredibly complex packing puzzles. In Tetris, right, you're trying to fit these falling blocks together to make perfect lines. In a warehouse, people are trying to fit thousands, maybe millions of different products onto shelves. But the goal is exactly the same. Use every last bit of space and leave zero gaps. And just like in Tetris, there is absolutely a science to winning the game.
And the official name for this science is slotting. Now, to be clear, we're not talking about the big picture, like where the aisles go. No. We are talking about the super specific, box-by-box decision of where every single thing is placed. This is layout on a micro scale. And that careful placement, that's the secret weapon to getting more stuff into a warehouse and, just as important, making it way faster for people to find what they need.
To really wrap your head around this whole thing, we've got to start small, like really small. So let's forget the entire warehouse for a minute and just zoom all the way in on the very first decision that has to be made. The one that starts with just a single cardboard box. It sounds kind of basic, right? But believe it or not, even a simple rectangular box can be put on its side or stood on its end. There are actually 6 different ways it can sit on a shelf. And I know, that might seem totally trivial, but that one choice right at the beginning is the foundation for everything else. It actually dictates how well you can use the space not just next to it, but behind it and above it too. And here's why that matters so much. The second you place that first box, you basically create this invisible column of space right behind it and right above it that's now pretty much useless for any other kind of product. So what's the only smart move? Well, you fill that entire column with more of the exact same thing. They call this a maximal arrangement, and it's rule number 1 for making sure you don't waste even a single pocket of air. And look, this isn't just guesswork. We're talking about pure mathematics here. For any box and any shelf, each of those 6 positions gets a hard number, a space efficiency score. Just look at this example. For a simple little 1x2x3 carton, one orientation gets you a pretty weak score of 0.57. But just by turning that same box a different way, you can jump that score all the way up to 0.86. That is a huge improvement from one tiny little decision. So here's the bottom line on this. By running the numbers, you can find the single best way to position that box to use the most space. Hitting that 0.86 instead of settling for less is the first, most fundamental building block of a super efficient warehouse. It's a small choice that when you multiply it by millions of boxes makes an absolutely massive difference. All right, so we've mastered the single box. But now, let's zoom back out and level up the complexity. Because now we have to pack an entire shelf, not with just one kind of box, but with dozens of different kinds, each with its own size and its own perfect orientation. This is where the real-life game of Tetris actually starts. At its heart, what we're talking about is a classic puzzle in computer science called the bin packing problem. Forget warehouses for a moment and just think about packing your groceries. You have a whole cart full of stuff, all different shapes and sizes, and you want to use as few bags as possible, right? Well, that's it. That's the bin packing problem, and it's famous for being incredibly hard to solve perfectly. So how do you even try to solve it? Well, you use algorithms. The most basic one is called next fit. It's like the impatient packer. It tries an item on the shelf it's working on, and if it doesn't fit, boom, it gives up on that shelf forever and just starts a new one. It's super fast, sure, but man, it wastes a ton of space. A much smarter way to do it is first fit. This one's more patient. It takes an item and it checks every shelf that still has space, looking for the first good home before it even thinks about starting a new one. Takes a bit longer, but the payoff is a much, much tighter pack. But the real pro-level strategy, the most effective one, is called first fit decreasing. And the logic behind it is just beautifully simple. Before you even start packing, you sort all your items from the biggest to the smallest. You put the big, clunky stuff in first, creating a solid foundation. Then you go back and you fill in all the little nooks and crannies with the smaller items. That one simple step of sorting first gets you incredibly close to a perfect, waste-free pack. But here's the thing. A warehouse isn't just a math problem that exists on a computer screen. It's a real place where real people work, and the most mathematically perfect solution in the world is totally useless if it doesn't account for the people who actually have to go and pick all this stuff. The puzzle has another absolutely crucial dimension: the human factor.
And this right here is what people in the industry call the golden zone. Just think about it in your own life. The easiest place to grab something is right in front of you, somewhere between your waist and your chest. You don't have to reach up high, you don't have to bend down low. So that spot on the shelf, that's prime real estate. That's where you put the stuff that sells the most and also the heaviest items to make lifting way safer. It's just simple ergonomics, but it makes the work faster, easier, and can dramatically cut down on injuries.
And then there's just good old-fashioned common sense. You know, what do people buy when they buy pasta? Tomato sauce. What do they buy with a flashlight? Probably batteries. This is called product affinity. Storing items that people tend to order together right next to each other is such a simple but powerful way to save time. It means the person picking the order doesn't have to walk all the way to one end of the warehouse and then all the way to the other just to fill one simple order.
Okay, so we've gone from a single box to a packed shelf to the people working in the aisles. So now, let's zoom out one last time and see how all these smart little decisions inside one warehouse actually connect to the entire supply chain, all the way to you.
And this right here is where that whole product affinity thing becomes a straight-up superpower. Look at this data from a real warehouse. That first bar shows how often popular pairs, like our pasta and sauce, showed up in orders. And yeah, it's a lot. But check out the second bar. That's the stunner. It shows how often those pairs made up the entire customer order. It's almost just as high. So by putting them side by side, you're not just saving a worker a few steps, you're turning a two-item pick into a one-stop shop. It's just grab, pack, and it's done. That is a massive, massive speed boost.
And that efficiency doesn't just stop at the warehouse store. It ripples all the way out. When products are slotted together by family, so all the hair care products are together, all the baking stuff is together, they get shipped together. And this means that when a box shows up at your local grocery store, everything inside it belongs in the exact same aisle. Think about what that means. It makes the retail employee's job of stocking the shelves that you shop from way, way faster. It's a ripple effect of savings across thousands of stores. So, from the simple turn of a single box, to the complex algorithms that pack a shelf, to the thoughtful placement that helps a worker stay safe and do their job faster, it all connects. It's this hidden layer of science and strategy that's all around us in our everyday lives. So the question is, now that you know it's there, will you ever be able to look at a simple store shelf the same way again?